Hello students, I am Dr. Saroj Hole. Welcome to FIBSC class. Today I am going to teach you Norton theorem. Norton was a great scientist, Edward Norton. So Norton was a scientist. His area of active research included network theory, acoustical systems, data transmission. He held 19 patents on his work. He was from Columbia University. He was best remembered for development of dual of Thevenin's equivalent circuit. It is known as a now Norton circuit. He was interested in communication circuit theory and the transmission of data at high speeds over telephone lines. Norton began his telephone career in 1922. In another video, I will give you the detail of all these scientists which are related to the electronics, their history, their birth, how they work, and where they actually done all this scientific work, in which labs they actually work, and what are the different laws and various inventions they invented, various discoveries, inventions, whatever work they did. That a separate YouTube link I will send to you on this scientist. Okay. So today we will focus on Norton's theorem. Now Norton's theorem, the statement is any linear active bilateral DC network having a number of voltage sources and current sources with resistances can be replaced by a simple equivalent circuit having single current source in parallel with a single resistance Rn. Voltage sources, every complicated network can be replaced by a single current source and a single resistance in parallel with the current source. So such a complicated network is replaced by a very simple one. So this simplest one is known as a Norton's equivalent circuit. Now this IN is known as the Norton's equivalent current through the terminal A and B, and Rn is the Norton's equivalent resistance viewed back into the network from the terminal A and B. Note that the independent voltage sources are short circuited and the independent current sources are open circuited. Dependent sources will remain in the circuit for the calculation of Norton's equivalent resistance. Now, what is the procedure to find Norton's equivalent circuit? So there are many steps you have to follow whenever you are converting a complicated network into a Norton network. So first step is to calculate the Norton current. You have to remove the load resistance RL through which the current is required and short circuit it. So let the terminals of load are labeled as A and B. Therefore AB is the short circuited. Now step 2 is find, this is RL, so it is known as AB. Okay. Now step 2 is find the current to the terminal AB by applying KCL and KVL, Ohm's law or superposition principle. This current is the short circuit current and it is known as a Norton's equivalent current. So this is Norton's equivalent current. Okay. Now how to calculate Norton's resistance equal to the Thevenin's resistance. So for this purpose, step 3 is set all independent voltage sources as short circuit and current sources as open circuit. Dependent sources will not be changed. Now step 4 is calculate the resistance as seen through the terminals A and B into the network. This resistance is known as a Norton's equivalent resistance Rn. Now step 5 is you have to draw the equivalent circuit. Now replace the entire circuit by the Norton's equivalent current IN in parallel with the Norton equivalent resistance Rn. Connect the load resistance in parallel. Okay. So the given network and its equivalent Norton network is shown here. Now we will see the example. Actually, we will apply this Norton theorem to the given circuit in which 6 ohm, 3 ohm and 1 ohm, there are 3 resistances connected in the circuit and 24 volt and 12 volt batteries, 2 batteries are connected in the circuit. This particular network can be solved using superposition theorem also, Thevenin theorem also Norton theorem, also KCL, KVL, by Ohm's law also you can solve this. So the shortest way, the simplest way is Norton theorem. Now what is the example? Find the current through 3 ohm resistor by Norton's theorem for the network shown in the figure. Now the solution we will start. First step 1 is, what is the step 1? Calculation of Rn. Rn calculation is same as that of RTH, that is Thevenin resistance. So we will redraw the circuit by removing the 3 ohm resistor and short the circuit, the voltage sources as shown in figure B. So voltages are replaced by the short circuited, and 6 ohm and 1 ohm resistor is there. Here the 3 ohm is considered as a load resistance, so that is also replaced by the open circuit, or that is infinite resistance. Okay. Now from these 2 points, if you look into the circuit, what is the total resistance offered by the circuit? So 6 ohm resistor, that is R1 and R2, they are now come in parallel. So total resistance Rs will be R1 R2 upon R1 plus R2. So 6 into 1 upon 6 plus 1, that is equal to 0.857 ohm. So this is a Rn, or the resistance when you look into the circuit, a short circuit resistance. Okay, so that is known as a Norton resistance, or RSC resistance, or short circuit resistance. These are the various terms used for this. Now step 2, calculation of Norton current. Now I want to find out IN. So for that purpose, what I will do, consider the previous circuit, the first one. Okay, the main circuit. Now what I will do, short circuit the terminals A and B, that is the resistance R3, 3 ohm resistor, and the current flow through AB is IN. Now through this short circuit, what is the current flowing, I will find out. Okay, so now 12 ohm and 24 volt, 12 volt and 24 volt is in the, these are the two batteries connected in the circuit, and R1, R2, 6 ohm and 1 ohm is there. Only 3 ohm is replaced by the short circuit. Now what happens here? Due to 24 volt, I1 current is flowing through the branch AB, and due to 12 volt, I2 current is flowing through the branch AB. So the total current in the branch AB will be I1 plus I2, that is a short circuit current. So how will I find out this current? Now I1 value will be 24 upon R1, that is a 6. So 24 by 6 is the I1, and 12 volt upon R2, that is 1 ohm. 12 by 1 is I2. Now if I add these two, I will get 16 ampere. So total current in the AB will be 16 ampere. Okay. Now what is the third step? You want to draw the Norton's equivalent circuit. So I got 16 ampere IN, and Rn is 0.857 as you calculated previously. Now I want the final step is, I want to find out the current through the 3 ohm resistor, that is R3. So for that purpose, again I have to replace A and B. I have to put R3 is equal to 3 ohm in between A and B. Okay. So now you got this type of circuit. So now R3 and Rn, they are coming in parallel. So I want to find out again the total resistance, and then IL, that is a load resistance. So IL will be IN into Rn upon Rn plus RL. So IL will be 3.55. It's a very simple circuit. Just IN is coming to two branches. So you have to find out the branch current IL. You know that this current division formula, so you can easily find out. Okay, so this is the formula and you will get the current. So it's very simple. Using Norton theorem, you can replace complicated networks into a simple one. Now there are some examples given to you to solve as an assignment. Now what you have to do, there are total 2-3 assignments I have given. You have to apply Norton theorem for each circuit and find out the current in the given RL value. So here RL is 8 ohm is given. You have to find out here using a same thing what you have done in previous case. Okay, this is second assignment, second question in the assignment. Nortonize the following circuit. Here RL is not given, so you have to find out across the A and B, IN and Rn and equivalent Norton network. Now here in this case, the 2 ohm resistor is given as an internal resistance of 48 volt power supply. So that you have to consider whenever you find out the equivalent resistance in the circuit, when you look into the circuit, or when you replace 48 ohm volt battery. Here we cannot replace it by short circuit. You have to replace it by 2 ohm, because it is mentioned in the circuit. It is internal resistance of battery is 2 ohm. So do not short circuit, or you have to replace it by 2 ohm. Okay. So very simple. Now Norton is a given equation. Here also across A and B you have to find out the Norton equivalent network. Then question 4, here again you have to find out the Norton equivalent circuit. 4 ohm, 2 ohm. It's very simple circuit. RL is given, but RL value is unknown. So you can find out that value also. Okay. It's very simple. Thank you.